Hello, I'd like to welcome you to a presentation on the uh, demo of the application that it was built in the Building Data Products Introduction to Data and Analytics Engineering for Non-Programmers book. My name is Brian McMillan. I'm an enterprise architect, been practicing for 15 or more years, primarily focused on data and business intelligence architecture. So what we're going to be covering today is the data discovery platform. It's a web application backed by a database with reports and APIs that you can access to expose, in this case, sales data that was generated by a well-known retailer in the UK. So to start the product off, we've got to talk about a couple of disclaimers. One, you're going to see a lot of code. It may look intimidating. Don't let that intimidate you. 100% of the code is just the assembly of pre-written programs, whether they're Unix programs or standard Unix programs or custom Python programs that other people have written. 0% of this will be code that you will actually be writing. There won't be any bash scripts or Python scripts. It's mostly configuration. And the code's going to include a lot of comments, tests that are run, logging statements. So it really isn't as intimidating as it looks. Lots of patterns that are just going to be repeated over and over and over again. So you should be able to get a hang of it. So, first place we're going to start is we're going to make uninstall, and we are going to remove all of the code in the project, which is really beneficial because it means if you really mess things up, you can always start from scratch and rebuild from scratch. So what can you do in this program? If we type make help, we get to see a list of things that we can do. Everything from make all to execute a default task to uninstall to run. So we're going to start this project by typing make all. And then what this is going to do is it's going to grab the Excel file that we started off with as our source file. And then it's going to split it into a number of CSVs. Now we're using CSVs as an intermediate file format because it's something that's understood by basically every program. Every database knows how to consume bulk load CSVs very, very efficiently. So we're going to make use of the CSV files to decouple the application from our source. The CSV files will also be something that we can use to share our data with other people, and we'll see use of that. Okay, so we've built the app, we've built the solution, but as you can see, we don't have any data in any of the tables. So what we're going to do is we are going to grab the CSV files, and each of these are about 50,000 lines each, and we're going to load them in. Now they're split up like this to allow us to validate that incremental loading actually works the way we need it to work. But in this case, what we're going to do is we're just going to grab all the files, put them in our load directory, and then we're going to write make. So earlier we wrote make all. If you just type make, it will execute that make all statement. And then it will reprocess all the data. So it's going to take those CSV files, it's going to create the tables we need, it's going to load the data into those tables. Then it's going to process that through the entire, it's going to execute the data pipeline to move the data from staging, from our raw files into staging, and then into the other tables in the solution. So right now it's populating our SAT table. And the SAT table is a table that stores all the history if you're using the data vault modeling pattern. Likewise, there's a business SAT table that reflects the business logic that needs to be applied to that raw data in order to make it make sense. So what's happening right now is it's going through and it's executing the stock code preferred description SQL. And this turns out to be the constraint in the loading of the data. This query isn't very efficient by design. It takes longer than all the other queries to run, so that when you go to the point where you're tuning the system, you always want to start with the application the step that's going to take you the longest. Pass through that. We've loaded all the tables. You can see some information on the screen showing the number of records in each of the tables. Now it's calculating the metadata, like what are the most common and least common values in each of the tables, which will be stored into a table. And we'll take a look at that later. So we'll just let this process. This takes a little while. Executing documentation. Excellent. Okay, so now we've loaded data into the database. And our next step is going to be to deploy this to a local web server. So we type make deploy local. That starts a web server. Opens up in a web browser. And what you're seeing here is the Datasette web application. Now, the Datasette application was written by the person who wrote the Django Python framework, web framework. And what it allows you to do is to connect it to a SQLite database to a web application, and it exposes everything in that database along with a lot of really nice features. So we'll go through that. We'll spend some time going through all of these features. So what we're looking at now is the sales database. We've got some metadata for the database itself and the solution. Things like, where did this data come from? Well, we can include that in the metadata with a link out to the source for this data so that you could go and grab the data yourself if you wanted to. One of the things you want to do when you're building a data product is expose as much of the work that happens under the covers as possible so that people clearly understand, particularly if it's a discovery platform. You're not building a dashboard. You're building something to help you share data and to investigate the data before it's really fully understood. And we'll go through some examples of that. So now we're looking at this weekly top sales rank table. We can see the metadata about each of the columns. We can see a table with all of the data in it. Things like, here's the create table statement for this table, so you can clearly understand what are the data types behind it. How is this table created? For a simple table like this, it's really not much of an issue, but as they get more complex, you might want to know that. You might want to know more details. So we can filter the data by facets, which would be like the buttons in Excel and the buttons in Tableau. So we're going to add a couple of facets here to help us filter. So this data set has 6 months of weekly aggregated sales data. All of the headers allow us to perform some actions like hiding columns. We can sort the data a variety of different ways. Okay, so now we have a data set. We filtered it. We can see that the brocade ring purse has the highest sales revenue. Now, we might want to do some other things with this. One of the things that's exposed very nicely in this application is the ability to write custom SQL. So this SQL statement here reflects the filtering that we did earlier. Our order by statement, our removal of a column, and we can go in and edit this SQL query. So here's the top 10 of the top 10. It gives you the ability to look at the data in the application without having to export it to something like Excel to do ad hoc analysis. You can go through and build an ad hoc table or an ad hoc chart to help you visualize the data. So now we can see, what does the revenue look like across all of the products? So we have a number that are pretty high, are much higher than others. Now, if we want to export it, there's a convenient link to export to CSV. And we can just copy this data, save it off, bring it into whatever application we want. So let's go back, and we're going to look at the meta tables table now. To perform some filtering on this just to make it a little bit easier to see what's in this table and to think about how you would use it. All right, so now we're down to the SAT Online Retail table. We're looking at the description column, and we can see we've got 537 records in this table. Quite a few percentage-wise it's not many, but we've got blanks in there. We've got a lot of distinct values. Now if we look at the values themselves, we can see at the most common and least common, we can start to see a problem here. So we have records that should have descriptions in them, but don't. Well, they have descriptions of some kind of defect, wrongly marked, wrongly sold, as opposed to, something that really looks like a product name, like Party Bunting. So we're going to go, this will be one of the problems that we'll be solving later, and we'll walk through that. How do we go about solving that problem? Okay, so now what we're going to do is we're going to start to look at how we solve this problem. So in our analysis folder under our service, we have a query that we've written, pretty basic, joining up the Business Hub table with the Business Link table so that we can identify the preferred descriptions. So we're going to go and paste this into our SQL editor, run this SQL. Okay, looks great. You got a preferred descriptions. Unfortunately, if you look at the query, we've got an inner join here, which is going to, just join where we have matches. But we want all of the stock codes that are in the hub table to be shown because there are blanks. We've got things like gift stock codes that don't have any preferred description, and that's a problem we need to solve. So what we can do is write a little bit of code to help us out with that. So first thing we're going to do is we are going to write a coalesce statement to fill in the blanks. And this is another great thing about this application, particularly if you are not comfortable writing SQL code. The database is read-only. It can't be deleted. And you can go in and write code, play with it, experiment to figure out what works without worrying about ruining damaging the database. But you can write any code you want. So we're going to use this code to start to build out, okay, so now we've got a list of, we've said, if there wasn't a description, put the stock code in there, which is great. That's pretty useful. I will guarantee that there are other people in the organization who don't have a good list of preferred descriptions and are struggling with this. So maybe they can use our data product to be the source of truth for vetted stock code descriptions. Don't argue whether or not we should be doing that. Obviously, it would be better if the source was working properly, but we have the data we have. So where does all this get stored? What would we do if we had these SQL statements? Well, we've already talked about the metadata, but let's look at the data. Let's look at the metadata definition. So there's a metadata.yaml file, and it's got all of the things that we looked at on the web interface. Like here's the table that we've been looking at, the description, the column descriptions, and then we can take a query and we can put it in this query block to expose a query to the people who are using the application without requiring them to write custom code. And it's a good mix between writing a view or materializing a table with this information in it. And you'll see how this can be used here in a second. So we've got two queries that we're going to do. One is a preferred stock code description, which looks like what we just showed. Here are all the preferred stock code descriptions. But then we have another one that's for the ones that didn't have good descriptions, where the preferred description is null. Then we're going to present you with a table that has that information in it. Okay, so the queries are here. Preferred stock code description. This looks exactly like what we built manually. You can see the description. You can see the SQL query, which is handy. You're never going to be confused. You should never be confused as to what you're looking at. You could export this as CSV. You could export it as JSON. Now here's where this really gets cool. You see that this is a JSON. It's the preferred stock code description .json as opposed to .html. That's all that it takes to get access to the APIs for a particular table. So we're going to manipulate this structure a little bit by changing the format of the JSON document. So we turned it from JSON objects to JSON arrays. Now we're going to throw in some new lines in here to make it a little bit more human readable. So depending on the way your application needs to consume a JSON document, you've got a very nice interface to figure out how to get the data you want out of it. And it's simply pointing it to a URL. All you would need to do is point your application to a particular URL, and then it would just show up. So stock code cleanup. We've got the list of GIFs to GIFs. So what do we do with this? Well, what we can do is we can take this, export it as a CSV, and somebody could edit it. We could export it in some pretty format, if that made sense to give to someone. Throw in a presentation, say, hey, we need to get this problem cleaned up. Here's what it looks like. We could export it as JSON, and maybe there's another application that could consume it. Or if you really wanted to punish the sales manager, we could export it as YAML, and then they could go in and edit this. Now the idea would be go in, take this table, modify it, put it back on the server, and then we'll consume it just like any other data that would come in. And that way we can start to get a round trip of the data. Is this the best solution? No. Is it the easiest one to manage? Yep, it probably is. Okay, so Now let's go through and let's switch gears, and we're going to dive into the code. So we've stopped the local server. Going to clear our screen, give us a little bit more real estate, and we're going to take a look at how the GNU Make application works. It's GNU Make. So it's all driven by this make file, which is a configuration file. And what we're going to do is we're going to start to look through the structural patterns that get executed by the make application. Okay, so we're going to scroll through here. We've got some macros. We've got some variables defined. Let's go down to start with help. So this is our make help command. So the help command in this case is referred to as a target by make. Now targets are what gets executed. Sometimes they're just something that gets executed like help. Other times they're actual files that get produced, and we'll see examples of both. But help executes a series of tasks. One is echo something to the log, so that we can see standard output, so we can see what's going on, and then execute some command. This particular command happens to be kind of nasty, but what it does is it actually makes that nice table of what we can do when we need help. So here's documentation. This is another target. And this one has dependencies. So it has a dependency of the run command and also the metatables command. So before that gets run, or before that gets executed, we have to run the run command. And the run command executes tests inputs, extract the data, transform the data, test the tables in the database, test the outputs from the application, generate some metrics, and then perform some database maintenance. That's all part of the run command. So we'll go look at a couple of other examples of these targets. So the metatables command that also needs to be run as a prerequisite goes through and it runs some SQLite commands. As we're using the SQLite command line application to interface with our database. And we're just executing straight SQL. Drop the tables, drop the analyze table, drop the meta table, drop both tables, then run this application called SQLite Utilities Analyze Tables function against the database, save the output, which happens to save to the Analyze Tables table. But we want something that fits in our application, so we're going to rename the table to metatables. And it's the first version, so it's version 001. That way, if we were to change the structure significantly, we'd have a metatables 002. And that way, people could start to transition from one to the other. And we would have a much easier time. It would be much easier for us to make changes without disrupting our consumers. So again, pretty basic structure. You've got the targets and the tasks that are executed, and then the dependencies. So looking back at the tasks for the documentation, we run the tree command, the standard Unix tree command, which outputs a directory listing text file. Then this node graph command, which uses the graphiz application to generate a makefile node graph, boxes and wires diagrams of all of the tasks and dependencies in our makefile, which is really important when it comes time to debugging and making sure that you've got the flow of operations in your data pipeline working properly. So the last thing in the documentation piece is to generate some entity relationship diagrams. So here we're going to generate entity relationship diagrams on business tables in our business schema. We're going to use an application called Alchemy for that, which reads the SQLite file, and then we'll generate a diagram containing our business hub, our two business hub tables, our business link table, and our business sat table. So this gives us a way to generate, every time the application is built, we're going to regenerate all the documentation so that if we make a change to our pipeline, it's automatically updated without us doing any work. Table structure changes, it's going to be automatically updated. So let's go look at what these look like. So we're going to open up the files themselves, and we'll take a quick peek at a couple of these. So our business table entity relationship diagram here. You know, pretty simple. It doesn't need to be that fancy, but it is very helpful if you're doing development to know what tables do you have and what kind of relationships are you expecting to see in and amongst the tables. So just a little bit about the way Data Vault structures things. The hubs represent the business entities that you are concerned about. And there are lots of business entities in this data set, but we're only concerned about invoice codes and stock codes. We have to have this preferred description table because we've identified that, you know, the descriptions are not right. So we need to go fix that in order to be able to do the aggregations that we want to do so that we can get some value out of this data. So let's take a look at the directory listing. This is another one of those things that it's just easy to overlook. It's really nice to be able to look at a file that has all of the, you know, all of the files in your solution clearly laid out. And then we're going to look at the big hairy one. This is going to be a little intimidating to look at because there are a lot of, you know, even a simple pipeline is not simple. And there are some ways to break up the make file so that it's much less complex. But in this case, it's easier to just put everything in one big monolithic application, one big monolithic make file, so that you can see everything and work in one file. And it's, you know, you can refactor it and break it up to make it easier to understand later. But you can see all run does the extract, transform, it calculates the metrics, tests the tables, you know, runs the compact database commands. And everything is all built off of this online retail load CSV. So if something were to break, or more importantly, as you're developing this, it's helpful to go back and, you know, every time you build, this is going to be refreshed. It's going to reflect, you know, the current reality. And it's all programmatic. You don't have to do anything to make this work. So now we're looking at the steps for deploy local. We start the local, we test the local, we've got some config files, and then we build the local. Similar case we'll look at later where we deploy to Google's cloud infrastructure. Very similar flow. So it's nice to be able to see an outline of the entire data flow in your data pipeline. Now let's go look at the raw data itself. Okay, so we're going to open up it all starts with this Excel file. It's a good example to start with an Excel file because frankly, a lot of our work frequently starts out that way. And this is a great example because it is real sales data and it is not a clean data set. So you can see we've got two tabs in this Excel file for different years. And now we're going to go look at the CSV versions. Now, one thing we're doing here that's really important is you need to maintain the lineage of the data that you're working with. So you should, just as a best practice, add the provider code, which in this case is where can I find this file? Where did this file come from? When did I load it? That's the load date timestamp. And these two columns get appended to each of the CSV files that we're processing so that we can know if we need to step back or if we have data, the similar data coming from different locations that we end up putting in the same table because it belongs together, we'll know where it came from. We'll be able to do some slicing and dicing of that data. So now let's go look at how this works out. So again, you have the targets and their dependencies. So this in order to produce this CSV file, we are dependent upon the Excel file. So pretty straightforward. Now we can add local variables like this tab name that can be used by the tasks that we're executing to do certain things. So we've got this task that has been simplified into a macro. So if we're doing things repetitively and it's pretty consistent, the process is pretty consistent, it makes sense to take that code and put it into a macro so that we can reuse it. And it definitely makes the code much easier to read. So let's zoom up here to our macro section, find that extract CSV from Excel macro command. A little bit of documentation as to how the target needs to be formatted. Now we're using CSV kit in this case to convert the Excel file into a CSV file. So the first step is we extract the Excel to CSV. We're going to pull this particular tab name. And then there's the $ less than or equal, and then the @ sign. Those are all shorthands for the targets and the first dependency. And you'll see those sprinkled through. As you start to learn Make, it'll become a lot easier for you to understand that. Then at the end, we test the file. Did it produce a file? And then here's an example of the test file macro using straight, standard Unix commands. So if we're going to use the test command, so this is test-s is to test for the existence of a file. The # is not, just like the # in SQL can be used as a not. And then if it doesn't exist, then write something to the standard output to the terminal window that says, hey, this file doesn't exist. So you get some good feedback. Now Make does a good job. If a file doesn't exist and it needs a file, it will tell you, and it will stop the execution. But it's nice to have some additional feedback, and it's nice to get in the practice of writing tests. Now we're going to load the CSV. This is a little bit more complicated simply because we may have a situation where we have multiple CSVs that have been processed before we actually loaded them into the database. Or we're loading a set and we get new CSV files in. So we need to have some more complicated logic, and there's some if-then statements in here that do that for us. It's not terribly important to go through that. One of the big things that this one is doing is it is sorting and removing duplicates. So we're deduplicating the data before it gets into the database, just to speed things up. And then we're spitting out the results of the word count Unix utility to tell us how many lines of code how many records did we process. And that gets printed out to the terminal window so we can see, oh, we did 430 some odd records. And then if we compare that to what we loaded into the database table, it should be 430 some odd records. And again, as these patterns get standardized, you can start to move the custom tasks into macros where they can be leveraged. Leveraged in other solutions. You can use the same macro set in the same basic make file for the next data product that you need to make. Now we're going to load the data into our source table, which is simply using the SQLite import command. So native database bulk insert functionality. Every database has a bulk insert, a really nice CSV bulk insert capability. Use it. It's the fastest way to load data into the database. And then at the end, again, we use the SQLite command line application to run a quick query to count the number of records in that table. And then we remove the file. So that's how we get data into the database. Now, one of the cool things about that SQLite insert command is it will actually create the database for you when you load the data. Okay, so now we're going to load the SAT table. Little bit more, it's the same structure, a little bit more complicated now. We have one target and then we have a number of prerequisites. One, we need the SQL code that's going to load the data. We need to have the database tables in place, both our source table and our target table. And then we need to run that load source online retail is what loads the data into our source table. So we load the data into the, we make sure the source table is there. We load the data into the source table. We make sure our target table is there. And then we execute the SQL command to load the data. So let's go look for that that execute SQL statement here. Yeah, we're just going to scroll through and look for the macro. All right, there we go. So execute SQL. SQLite utility against our database. We're going to read the table that's in the dependency, or a table that's a prerequisite, and then we'll just close out that command. So that $ less than again refers to our dependency. And it's the first dependency. You may have multiple dependencies, but just read the first one. Wait on the other ones to be complete. Use the first dependency to execute. Then, run the code. And that # at symbol refers to the target itself, which is really useful if you're outputting to a table. And again, you can have all kinds of internal variables. We'll revisit this Vega report near the end. Okay. So now let's look at some SQL code. So we're going to load, we've got the data into stage, we've got it in our SAT table. Now what we're going to do is we're going to look at how that whole process works. So the first step is creating the table. So the SQL code that's going to be executed is pretty straightforward, standard, create table if it doesn't exist statement. I'm going to assign some primary keys to that table. Do a little bit of typing. Pretty straightforward. Now we're going to load the data. This is a little bit more complicated. So in order to make the code more readable, we're going to use what are called common table expressions to break up the code into logical, understandable bite-sized chunks. So when we're talking about loading data into a database table, we're going to use a pattern. We're going to use a source, target, and then an insert pattern. So first query we want to talk about is what's our source file. Let's get that set up the way we need it to be set up. And don't worry about the structure here. We've got some data vault specific things going on. Then we have our target, which is pretty straightforward. And then we have our insert statement, which is basically just doing a join on the source and the target to get the data that doesn't exist. And then we do an insert into this particular table from this select statement. And then what that does is that appends the, in this particular table, it's an append only table. We don't do updates in this table, only inserts. And what that allows us to do is to keep a history of the records as they change. So we may have one invoice that over time changes 5 times, and we would be able to look back through this table to see the history of the changes, which is really handy for debugging, and it's really handy for going back and asking questions like, what did this look like last month? Okay, so when you're done with all that, you need to clean out the source table. So what we're going to do is we are going to define source and target again, and we're going to execute a delete statement against our source table to remove any records that exist in the source table that we already have in the, that exist in the source table that we already have in our target table. And that basically just cleans out our source table. So pretty straightforward SQL pattern. Standard SQL. The code may look a little, if you're not used to doing, most analysts aren't allowed to, do this kind of work. So there's a little bit of a learning curve to understand the pattern. But once you get the pattern, it's just a matter of repeating it for your particular table over and over again. Okay. So let's go down and look at our tasks for loading this data. Okay, so the next step in our process is to think about deploying this to production. We've already got the data set there. We're going to deploy to Google's CloudRun infrastructure, which is a serverless platform that allows us to build a container that contains both our web application and our database, and we can deploy it as one solid artifact. So let's look at the target and the dependencies here. So start gcloud is our command that we're going to execute. We need to build the solution, and we need to test the solution before we can start up the server, or before we can promote it to production, and then it will automatically start up. So the build step is pretty straightforward. Take our configuration files that are in our various configuration directories and put them in our opt directory, which is where our servers go. So this holds the deployment artifacts that we're going to be deploying. Now, when we run start gcloud, we're going to run a Datasette command called publish, and we're going to publish to CloudRun. And we're going to say, use this database, use this metadata, use these configuration parameters, things like memory. We can set memory. We can configure a database with 8 gig of RAM if we want, right from just changing some configuration file. So make deploy gcloud. Now this takes a while, but what it's doing is it is provisioning the infrastructure for us. And it's taking our code, bundling it up into an artifact, sending that to Google's infrastructure, and then Google will take care of setting up our servers for us, provisioning everything, getting all the networking stood up with zero configuration on our part. It really is nearly, it's a no-ops type platform where there are very few, there's very little need once it's initially configured for you to do anything. So we're going to wait for this to upload. It's a pretty big file, pretty big database. We're just going to sit here and wait. Now, the other great thing about the Google CloudRun infrastructure is it is a scale to zero infrastructure. So if the application isn't being accessed, if no one is hitting the web server, querying the database, then the server gets shut down. And the next time, so it could be shut down for hours. And then the next time somebody goes to access that data, the server is going to start up again. And there's a little bit of a lag, but then the server starts up and it runs as long as it needs to be running, as long as it's being used, and then it shuts down again. So what that means is that you are only billed for the number of seconds that your server actually is running, producing value for you, not for when it's not. So, gone are the days where you have to run a server 24/7 and pay for it. You only pay for it when you're using it. Now, the other nice thing about the Google CloudRun service is that it will scale up your application as well. So it will go from 0 instances running to 1 instance to multiple instances, depending on the load that server is seeing. And what it does is it stands up another version of this application, which is why it's kind of a beautiful thing that we're publishing our data with our application side by side. So we have very tight coupling for our data product, which makes it very easy to replicate. So if we need to, if we have a huge spike in utilization and we need to spin up, 10 instances to be running in parallel, it just does this for us and we don't have to do anything. And we certainly don't have to pay to provision 9 additional servers when most of the time the application is sitting idle, which, you have to admit most reporting applications, analytics applications are just sitting idle most of the time. Certainly no one's using it in the middle of the night, unless you're a global company and all of that kind of stuff, but then maybe you should have another instance running in that region that you're in, which you can also do. So right now, it's deploying the container to our project. It gave us a URL. We'll wait for it to do some tidying up here. All right, this is the exact same application we were running locally. All the same functionality, just running on the public internet now. Okay, so one thing we didn't talk about this report. One of the problems that we have, we're trying to treat everything as code. And for things like the SQL and the data pipeline, pretty easy to do that as code. Producing our graphics as code in a way that doesn't require us to write, a massive Python script is difficult. So we're using an application here called Vega, which was created by the University of Washington. And it allows us to configure a report just with code. Now, one of the interesting things you can see as we're scrolling here is we have some products that we have pretty consistent sales on, and other products where we have very low sales on. You can go through and you can see, let's look at the source code for this. It's a JSON document with a pretty simple structure. So again, we're making the code under the covers visible to everyone so that you can clearly see what's going on, which is a real help if you're learning how to make things work. If you're learning how to do this yourself, it's helpful to be able to see code that's actually working, running, in the wild, that you can then go and start to edit. So let's take a look at how this works. So the Vega, the people who manage this application and created this application have an online editor. And because our server is on the internet, we can just click over to it and go in and edit the code manually. And again, this is non-destructive editing. We're not going to break anything. We're not changing, we're not altering the code that's running in production. We're just modifying the code that's there in a read-only way. So change it to weeks, change it back to months. That makes sense. Now let's go and change the, see if we can improve the look and feel of this. Change the bars to points. Well, it looks okay. Let's try lines. No, that doesn't look very good at all. Okay, let's go back to bars. This report looks pretty good. Serves its purpose. What are our top performing products? When do we sell them? See a big push in November for December sales, which makes total sense. Then we have a lot of products that we sell a lot of, but very sporadically. And maybe that's what we should spend our time working on next. Okay, so now let's go look at how this report gets built. So in our app directory, we have some configuration documents. We've got, this document's basically a web page with a header and a standardized header and footer, and then our configuration code. We've seen this a couple of times already. The facet command is the thing that puts it into 3 columns and then splits it down by the preferred description fields. And here's what the resulting HTML looks like. And all this is simply just concatenating these 3 files together into an HTML document and then writing that file in the right directory. So it's pretty straightforward. And because if you get it promoted to production, if you get your data set promoted to production, it's pretty easy to then use something like the Vega-Lite editor online to modify that and try out new visualizations pretty easily. Okay, how do we schedule things? Because you have to schedule things. So we're using the cron application, standard Unix cron, which looks a little scary. There are these 5 asterisks, and there's lots of material online to help you figure out how to schedule things certain ways. And you can get some really complex schedules built, but basically you're going to be limited. I want to do things every hour. I want to do things every day. I want to do things every week. And learning those commands are pretty straightforward. So it just says use the make command, execute makefile all. You have to be explicit on what you're calling. And then what we're going to do is we're going to write the output, because we won't be watching the terminal window. We're going to write the output to this cron log text file. And that'll put both there's some commands behind here, they're behind my head that you can't really see, that will write both the standard output and the standard error to that particular file. So when we have issues, we can go back and we can look at the log file and try to figure out what happened. And because we've been very consistent about writing commands to the log, we can see that. Now there are some additional files in here. These are standard files that the Unix community uses, authors and readmes and those kind of things. Here's the license file. We're using the MIT license for this one because it's a pretty generous license. These are all things that you should add to a product to make it a well-rounded offering. So what's next? I think it's worth taking a look at the Google CloudRun console to get an idea of what this looks like. And we're just going to take a quick look. We're going to zoom out to 30 days. And, like I talked about earlier, you can see here in these charts how many container instances we're running. Like in this case, that case, we had 6 containers running at the same time. Now we've got 3. Now we're down to 1. Now we're back up to 6. And those blank periods in between, which you can see in the billable container instance time, we're only paying for the blue lines. We're paying for the number of seconds for those blue lines. got access to the logs. So not only are the logs written to a text file, but they're also written, the container has its own logging system. And the revisions allow us to easily roll back to old versions of our solution, which for a reporting application is fantastic. Because if you decide that you need to go back and, somebody's always coming back to you months later and saying, hey, last month it didn't look like this. Well, you can go back, reach into the cloud infrastructure, stand up or download that version of that application and take a look and see what the data really looked like. So we covered a lot of ground. This was a long demo. It really does cover all aspects of, starting the development of an application to promoting to production in an automated, repeatable fashion. And I don't think a lot of demos show that. And it's helpful to see what are all the moving parts that are involved. Hopefully the patterns were pretty simple. We use standard command line utilities to accomplish our tasks. We can string those together in a variety of different ways. We can execute tasks based on their dependencies so that we make sure that we do, A, then B, then D, then C. And then we can schedule those tasks to run unattended. And that's really what I wanted to try to accomplish with the technical side of the book, is to show you that it is possible to do things that you can't do this in Excel, and you don't need to spend lots of money on a whole suite of complicated cloud-based applications to get your analytics application available to as many people as need to see it in a way that's very cost effective. So I want to thank you for your time. And if you have any questions, you can reach out to me and I will be happy to answer them. Now, for people who like like architecture diagrams, boxes and wires architecture diagrams, this is one way that you could use a data discovery platform like this. So you have your standard business intelligence platform. You've got your data warehouse, you've got your production pipelines, you've got your reporting system, you've got your BI dashboards and reports. But what happens when you have new data that you need to investigate? What happens when you need to combine, your official data in ways that are new, but you're not sure are going to pay off? That's where something like a data discovery platform comes into play. You can you can grab data from wherever you need to grab it, run it through this ad hoc orchestration pipeline, publish it on your data discovery platform, manipulate, investigate that data, figure out what you have and what you don't have, bring in new data where it's necessary, pull data out, build new tables, really figure out what it is you need that's going to bring you some value, make that available in a consistent way so that people can do their job. And that fits. Now, when you've got this investigative work done, when you're done exploring your data set, then it's time to consider, well, how do we get this back into our production environment? And, one of the things that we've done in this application is we made the assumption that you were using the data vault structure to structure your data warehouse. You could have used other ones, but if your discovery platform patterns match that, it's pretty easy to say, oh, okay, I need these new tables added to the current business vault from this data, not this data. And then we're going to make that data available, and we now know what kind of standard reporting we want. So we'll build that in our dashboarding system. So leave you with a quote by Ice-T. It was by Ice-T before it was Jay-Z. And I'll leave you with that. Thank you very much. Again, if you'd like to walk through this yourself, if you'd like to see how this project would actually get executed with stories and discussions around the how and the why, my book, Building Data Products, Introduction to Data and Analytics Engineering for Non-Programmers, is available on Amazon, Apple Books, Gumroad, in a variety of different formats. So you can go to the website minimumviablearchitecture.com, or go to Amazon and look for Building Data Products, and you'll see the book. And if you have any questions, feel free to reach out to me. My email address is included here, and I'm active on Twitter, so feel free to reach out. And I would be happy to talk with you at any time if this is something that you might be interested in investigating further. And with that, thank you very much.